Once upon a time, in a magical land, there lived a little named Jack, and he was very, very poor, but that didn't really matter, because deep down inside, he was really good at math. It didn't matter that he was also a jerk that really loved money. He was just good at math, which is what's important in life. So yes. So one day he was walking in the street, doing some math problems, doing some integrals and some other fun calculus, and he bumped into a person. Oh, I'm so sorry, young sir. As my apology, here are some magical beans. Here you go.
Thanks, bud.
And Jack, knowing that these weren't ordinary beans, decided to plant them in the ground. And then they grew into a really big pole that he climbed because he was curious and mathematical. And she climbed the pole. And she got very high up into the sky, into a big castle that was in the sky. And she was like, whoa, a castle. Yes. And then there was a big giant walking through, and he hated math. Fee, fi, fo, fum. I hate math because it's not fun and integrals.
But Mr. Giant,
What?
math is super fun.
No, it's not.
Yes, it is.
No, it's not.
Yes, it is.
Okay, well then show me how to do an integral.
You know what? Maybe I will.
Okay, good. Good, do it.
You just watch.
Hello, class. Today we will be learning about indefinite and definite integrals, starting with U substitution. So a long time ago, back in the land of novices, we saw antiderivatives that were like this. And we were like, awesome, I can do that. But then we got derivatives that look like this. And we had to take the antiderivative of this, and then we were like, holy crap, I can't do that. Oh my god. But that's not a problem anymore, because we have U substitution. Yes, right. So U substitution is basically, don't worry about it, Caitlin. Just like an easier way to take the antiderivative, because you substitute in U for a variable and it makes it a lot less confusing and stuff. So what you're doing is you want to look for the part that you want to substitute in for U. Usually it'll be like something that's raised to a power. In this case, it'll be like this right here. So you want to set that equal to your U, and it's equal to 1 plus x to the 4th. And then you have du, which is your derivative of U. So you take the derivative of that, and that's just 4x to the 3rd. And so then you want to like plug it into the integral, and this is indefinite, so you don't have to worry about bounds. You're just looking for it in general. So you have your U to the negative 1/3 du, and then it goes on from there, which is later explained in the video, but this is just like the basic concept.
Okay, so evaluating a definite integral is pretty much the same thing as evaluating an indefinite integral. Here we have our normal integral right here, but we also now have bounds. A is the lower bound and B is the upper bound. So we go through the same process and get our little expression. So if in this problem, if A was 1 and B was 2, at the end of the process you've just seen, you've got something that might have looked something like this. Kind of like that. Now I'm going to put this little line here to show that we have to plug our bounds in. We're going to plug in the upper bound first and then subtract the plugged in lower bound equation. So what I did was I plugged in my upper bound first, and then subtracted my equation with the lower bound plugged in from that. So it's pretty much this, except for x, you have first 2, and then you have 1, and that all equals 1 over 14. So for definite integrals, you should get a numerical answer like that.
This is our indefinite integral problem. And as you can see, there is something in the denominator which you can't have. So in our next step, we are going to move that up to the top to simplify it. This is the indefinite integral simplified. According to our integral, we will replace 1 plus x to the 4th with the letter u. So then the derivative of this must be 4x to the 3rd. In order to get the correct derivative into the equation, we multiplied the outside by 1/4 and the inside by 4, which is really 4 over 4, which is equal to 1, so it doesn't mess up the equation. In this step, we replaced 1 plus x to the 4th with u, and 4x to the 3rd times dx with du. We were then able to remove the derivative, which was du, by taking the antiderivative of u to the negative 1/3. We then simplified the equation by multiplying 1/4 with 3/2. Because u is equal to 1 plus x to the 4th, we were able to replace the u in the equation with 1 plus x to the 4th to give us our final answer of 3 over 8 times 1 plus x to the 4th to the 2/3 plus c.
This is the definite integral. So what we did was we took u to be the innermost part of the integral, and then we just took the derivative of u to get du. Okay, so what we did was we substituted u and du into the equation, and so we're left with the integral of u du. Then we just simply took the antiderivative to get 1/2 u squared. Then we just plugged back in for u. Substituted into the equation the upper bound of the integral. Then from that we subtracted when the lower bound was plugged into the equation. Simplifies to pi squared over 72 minus 0, which equals pi squared over 72.
So,
I never knew that integrals were so easy. All this time I misunderstood. I actually love math. Thank you, Jack.
Anytime.
Sometime.
You're on.
Okay.